Welcome everyone to the first restarted version of the Comet Meetup Industry Q&A. We're still going to figure out exactly what we're calling this, but we're so excited to have our two guests today, and we're very excited to have all the folks coming into the chat. And I had mentioned just getting started before we do our round of introductions. Just want to let y'all know that there is a Q&A section down at the bottom of the Zoom screen here, where y'all are welcome to submit your questions. We'll get to those sort of at the end of the session when there's time. We'll have about 15 minutes there. And you're also welcome to chat with each other in the chat and talk about these ideas we're talking about, and just keep the conversation lively and things like that. Without further ado, I want to jump right into it. I'll introduce myself and then let my colleague Drew introduce himself really quickly, and then we'll introduce our attendees, participants here, and then we'll start asking them some questions and really get into it. So I'm Austin. I'm the head of community at Comet, a nebulous term, but what I really focus on is things like this: community initiatives, ways to bring people together in the community, talk about pressing things in data science, machine learning. We have a lot of things planned over at Comet, and this is very much one of them. So we're very excited to restart this series. And I'll be emceeing, but then my colleague Drew, who I want to allow a chance to introduce himself, will also be tag teaming with me and asking some of the more technical questions. This is more he'll introduce himself. Go ahead, Drew.
Yeah, thanks, Austin. So hello, everyone. Thank you for joining us here today. My name is Dhruv. I'm a data scientist at Comet working on growth and community initiatives. Yeah, hoping to have a great session. Thank you, Abubakar and Jakub, for joining us. Both of you are working on some really cool stuff. So very, very excited to have you here.
All right, thanks. So with that, let's jump right into it. I'm going to start this off just with a quick round of introduction, starting with you, Abubakar, and then moving on to you, Jakub. Just tell us a little bit about yourselves, your journey in machine learning or in the field of computer science, or your interest in the field, and then how you got to where you are with your current companies that you all are working on. So Abubakar, go ahead.
Sure. Yeah. First of all, thank you so much for having me here. I'm really looking forward to the discussion with everyone here. So my journey with machine learning actually started at Stanford. So in 2016, I got admitted to Stanford's PhD program, and the PhD was actually in electrical engineering. And when I started, I wasn't doing machine learning at all. I was working on medical devices, and in particular, how to charge medical devices from a distance, like wireless charging. As one part of this project, we had to figure out how to have like certain proteins bind to our medical device. And that became a very difficult problem, and it involved a lot of machine learning. And as I started working on that problem, I became really fascinated by machine learning. I was drawn in. I think a lot of people are. And I completely shifted my area of research. I started working with Professor James Zoe at Stanford, who's a fantastic professor. And we just started looking at one application of machine learning to medicine after another. It was just really fascinating work. And at that time, deep learning was taking off, but not that many people had developed methods specifically for medical problems. So we started working on this. And then a few years into my PhD, I noticed something that I noticed a very frequent pattern that I would work on, which is I'd build a model, but then I'd want to share it with with a domain expert, like a doctor or a biologist. And the tools to do that were not so developed. So I had to write a lot of boilerplate code again and again. I had to familiarize myself with a lot of different technologies from deployment and front-end web development. And I thought that there should be a better way. So I took a lot of what I was doing, packaged it into this library called Gradio. We released the library, got a lot of open source traction as well as VC interest, and then started a company based out of it. And that's what I've been doing for the past couple of years, just working on this full time. And I'm excited to share more about that when we dive deep into it.
Thanks, Abubakar. And I think you made a really interesting point about domain expertise and like this ability to collaborate, which is, again, I should have mentioned, this is the framework of this discussion, is collaborative tools for data science and machine learning. That seems like a very particular, and I might want to return to that as of how domain experts can be benefited by these tools in addition to actual machine learning researchers themselves. So I might want to return to that, but that's a great point. Jakub, how about you? Let's hear from you about your journey.
Yeah. Hello, everyone. And same here. Thanks a lot for organizing this, and really looking forward to the discussion afterwards. So quick few words about me. My journey into data science and machine learning started through data visualizations. So I was very much into data visualizations as I was growing up, doing lots of stuff around generative art, and just like mostly just trying to see what are the things that we could do to better communicate the patterns and findings in those data sets. And over time, as I was digging deeper into all these different ways how we could visualize data, you naturally start to dive deeper into code and trying to solve some of the problems there. I went all the way to start writing various tools for developers. I was quite engaged in developer tooling and did quite a lot of work on some of the more advanced concepts around debuggers. I did spend some time working on Mozilla Firefox in the past. And then like one thing led to the other. I got into mostly like, I would say, academic sphere of machine learning. I did my master's at the University of Cambridge and spent some time just like doing stuff around computer vision and just general ML stuff. But this was still not the space, like the place where I got like super deep into ML. Like up until that point, I mostly had academic knowledge, like something that understood how it works on a theoretical level. And then suddenly I became CTO of a data analytics company. And that was the moment where like, everything changed. And suddenly like all these beautifully defined problems turned into something very much different from what I was used to. And I was a CTO of a data analytics company. We were working primarily with movie studios based in LA. So you can imagine there was just lots of stuff. We were working on everything from box office prediction, meaning how much a movie is going to make in theaters, all the way to finding the right audience for specific genres. So you can probably imagine if you have a Star Wars or some like major blockbuster movie, there are some interesting things you can do around the audience targeting and segmenting. But the same thing you can actually do even more interesting when you have some niche art movies. And we were working on some movies that went on to win Best Picture and Academy Awards. And these were actually much more difficult problems because like we were working on some like super niche movies around like LGBT drama targeted to like African American audience, and like finding these people across the internet suddenly became this like very interesting challenge. But it was a challenge on two different layers, everything from the actual whole data pipeline, like how do we get all this data, how do we find these people, but also an organizational challenge because the company grew from 0 to about 120 people in about 3 years. And being a data analytics company, there was actually a significant part of that headcount was data analytics or engineering team. And like all this knowledge about machine learning models started to come pretty short as we're trying to figure out, all right, now we have first 5 analysts, like they can collaborate, fine. Now we have 10 data analysts. There's no way they can collaborate right now. And we start to dig deeper into all these advanced topics, took inspiration and best practices from the developer tooling world. And one thing to another, I just got super deep into this topic. And now I'm a founder and CEO of Deepnote, where we are building a better data science notebook, which is focused on 2 things. First, productivity of individual data scientists and data analysts on a team, but second, on the collaboration aspect. And we can probably talk about this in a bit more detailed fashion later on, but this is roughly my introduction to this space.
Oh, wow. That's a really interesting one. Thank you, Jakub, for sharing that. Not necessarily the direction I was expecting this to go with, like doing it for films and Oscar award winners and stuff like that. That's pretty cool. Thanks, guys, for sharing. That's 2 very interesting ways into this. And I think I can see some of the through lines where you started identifying some of these problems that could be better solved by collaborative tools and things like that. I want to kick it over to Drew for the next question here. He's got something for you.
Yeah, so I can kick this off. My question, there is like this temptation to think of like model development as being a product of an individual researcher or data scientist who owns that entire pipeline. And this might be like analogous to like the 10x engineer myth in like software engineering. But I think like the reality is that to successfully like launch a model that can create real value for an organization, it requires like collaborative effort from many different like technical and non-technical stakeholders. And they have to have both a shared understanding of the problem as well as the proposed like ML or data science solution. So in this context, I'm curious to know your take on why tools for communication and collaboration are important for like the progression or evolution of the field.
Yeah. Jakub, do you want to start this one?
Yeah, sure. So when we are talking about collaboration in ML as a domain, it's actually, sometimes it makes a lot of sense to define what kind of stage, what stage of the collaboration we are talking about. Because you may know this, being a data scientist and being a data analyst can mean widely different things. And the same thing applies to also a machine learning project. The collaboration at the beginning of an ML project looks significantly different than the collaboration at the end of the project lifecycle. So for example, Gradio does an amazing job around like sharing the results and collaboration. Like once you have some kind of model that you want to share with others. My experience probably comes more from the earlier stages of model pipeline, where you're just beginning and trying to understand what the problem is in the first place. And we've seen it happen among our users, just like seeing how they are working in notebooks, because notebooks tend to be this first prototyping environment, the first go-to place where you go to do some kind of exploratory programming to see what kind of data set you even have and what are the things that you could do with it. What we have seen is that even though most of the work that machine learning engineers or data scientists do, even though it becomes, let's say, 70, maybe 80% of time, something they are spending working on alone, those remaining 20 to 30% make all the difference. And in these examples, I like to actually look at some other industries where the collaboration model might have evolved already, and we are seeing we can just take some inspiration from those places. First one being just like general writing. You probably all remember how we were all writing documents in Microsoft Word, and once we were finished, just package it, send it over in an email, and then after final 1, final 2, final 3, like all these like final 15 doc, like you finally managed to have something you could work with. This radically changed with Google Docs. And you can probably imagine that the first thing that writers, like people who actually like had the title of like writer in their role, they just look at it and just like, no, I don't want any kind of collaboration. I don't want people like behind my back, like looking over my shoulder, what I'm typing on a computer, because I'm in the space. I don't want anyone to be dealing with while in my flow. But this is not the collaboration we are talking about. The collaboration happens once you have the first draft ready, like once you want to send it to someone and you want to hear their early feedback. And we have seen this transformation happen not just with document writing. We have seen it in design, for example, where people are working with like these huge Photoshop files. Suddenly like Figma came along and you could collaborate in real time on your prototypes and design UIs. And even though you are still spending most of your time working deep down, like in a deep flow stage, just like by yourself, there is this moment where you just ask for feedback and just reach out to someone. It's like, hey, does it make sense to you? And this is the same thing that we are seeing in the early stages of a model lifecycle, where we are doing lots of exploration. When you are working in a notebook, you probably notice this yourself. Actually, a huge number of your notebooks don't end up looking pretty good. They are pretty much just like quick experiments which are thrown away and you move on to something else. And the reason for this is that there is like what we are really experiencing is like fast iteration cycle. And we just need to do some work, do some querying, do some analysis, quickly ask for feedback, go back, do another iteration of what we are working on. And that's where the collaboration starts to play significant, because if we don't do this, like imagine that you have your model that you've been training for 2 days, and then you send an email to someone, and then suddenly you have like model number 15, and that goes into production. That's going to be super inefficient compared to having this early feedback and super fast iteration cycle that this like new generation of tools which allow for real-time collaboration allow you to do.
Awesome. Yeah. So Jakub mentioned something which I think is very interesting. This transition from the academic kind of machine learning to machine learning in the real world. And one of the big differences that happens is when you're in an academic setting, oftentimes you're optimizing for your test set, right? So you have your model, you have a training data set, you have a test set, you're optimizing for the test set. And one of the things that we've noticed is that when you go to the real world, oftentimes that's not enough. What happens is you could have a model that's doing great on the training data, even great on the test data, but when you actually deploy it, so I'm talking about it maybe at a little bit of a later stage than what Jakub mentioned, when you actually deploy it, models tend to fail all the time in costly ways for companies, in maybe embarrassing ways, bad PR, if the model has been deployed externally, and sometimes even in silent ways. So the model is making bad predictions, but you don't even realize that. So why does this happen? Essentially, the reason it happens is because your real world data doesn't look like your test data. Or in other words, you've been optimizing this entire time for your test set, but you haven't been optimizing for real world data. And that's natural because I think most of the time as machine learning scientists, we focus on the test set because that's what we have. Someone has given us data, so that's what we're optimizing for. But we think that's actually a bad paradigm because it leads to all of these problems that I just mentioned. What would be far better is if you were optimizing for real world performance. You deployed a model as quickly as possible, and then you got feedback on how the model is doing in realistic settings, and then you adapt your model appropriately. And so this is one big motivation for why we built Gradio, because we wanted to make that process for deployment and putting your model in the hands of a domain expert, whether that's in the medical setting or it's in the business setting, or there's lots of different use cases here. Sometimes applied scientists are the ones that are using these interfaces. Get them using your model and giving you feedback on, hey, the model isn't working here, the model is working where. And we've seen this now in so many different settings. This feedback leads to a lot more robust models, which end up getting trusted as well by a lot more by your interdisciplinary team. Because what ends up happening is oftentimes, like as machine learning scientists, we're the producers of these models, but there's someone else that's the consumer. And when we're working in isolation and we're working in these silos, oftentimes when we ship out this product, there's no reason inherently for someone to trust it. Like, we're just giving them a tool, but why would they trust it? And as soon as the model makes a very embarrassing mistake or something that no human would do, then they're like, oh, then the people who are supposed to be using this model, okay, I'm not trusting this anymore. I would never make such a mistake. Why would I trust it? That's why I think it's very important, and we're seeing this in a lot of different spaces, everything from like clinical trials to business teams. Now trying to use the model even before it's deployed, so that they can give feedback on the model and make sure it's something that actually works. And that ends up leading to, I think, this kind of collaboration, which is maybe, I think, at a later stage than what Jakub is saying. Now, when you want feedback, not necessarily from machine learning scientists, but maybe from the actual users who are going to be using your model. And that ends up leading to models that are actually more robust and more trusted by the people that should be using them.
As somebody who really cares a lot about community and getting feedback and really being transparent and open, like that really appeals to me at Abubakar. That's sort of that perspective that collaboration also happens with your end users and should happen with your end users. And I think that's just like a solid thing to do, regardless of what your sort of business case is or what you're exploring. And then Jakub, I was thinking, I love that you mentioned writing after my own heart. I got a master's degree in poetry writing, so it brought me back to the workshop days of passing around the Word docs and having the red line strike throughs, and very nerve wracking, but much better in the later days of that. You kind of both started dipping into this. I think the next question I want to jump into is, given, and you maybe Abubakar a little bit more, you were talking about collaboration with the end user as a problem you're specifically solving at Gradio. In the context of what you're saying around iterative development and the different stages and things like that, what Deepnote specifically, I want to take a look at what specific problems that you've identified in developing Deepnote that you're trying to solve for with collaboration, just digging a little bit deeper and more specifically, I guess.
I think there are multiple classes of problems. There's not just like, I won't be able to go out and say there's this one collaboration problem. There's like different things that happen as your team starts to grow. I can give you an example. Once you have a bigger team, something that we have seen in the past, there is this natural churn in your employees. Some of them will inevitably leave the company. And what I have seen in the past, and it was eye-opening to me, where this amazing data scientist put in the notice, 2 weeks passed, and suddenly like it was their last day. It was all heartbreaking, and we were all just talking about like how we will miss them. And they put their laptop on the table, and no one ever opened it. Like all those models, like all these notebooks, like all these just like years of work suddenly like never seen the light of day, because no one had any idea whatsoever, like what is on the laptop, how to even get it running. And this kind of became a really good example of what tools which don't encourage collaboration by default end up doing to your team. Like they're just naturally become these kind of silos. Even if you are trying really hard, like there's just going to be someone's hard drive just sitting there that no one has access to. And if you've ever received like a project from someone and there's an absolute reference to file on their disk and you just couldn't continue, you probably know what I'm talking about. So this like inherent data silos that get created as people need to pull the work, do it on their personal computer. This just happens. And even if you have the best process and the best team in the world, like there is just no way how we're going to avoid this kinds of situation. I would say this is the first type of problem that we have seen when it comes to collaboration. There is a second type, which is more about handing over of your work. At some point in the model development lifecycle, you are going to put this into production. And this is something that Abubakar might be able to talk about in more detail. But essentially, you have this interesting problem where there was a lot of time put into experimentations, into prototyping. Now you have to hand it over because you want to scale it across many nodes in your cluster, which is not necessarily the role for a data analyst or data scientist, but it is something that software engineers or people from DevOps have mastered pretty well. And just having this wide, just like this divergence in different, like in environments where the development happens and the production itself, you start to feel a lot of friction around handover of that work. So this is the second kind of collaboration problem that tends to happen. And again, this is not something that you can just easily work around with, because if you have a data science team, it is inevitable that this is going to happen, that you will need to scale your model and you will need to bring it outside of the data science team and involve someone who is external to your team to help you out with its next stage. Yeah, I would be very actually interested to hear what Abubakar has to say around this, because I can imagine he has spent a lot of time dealing with these kind of problems. Exactly.
Yeah, definitely. So just to add to that, I think the problem that Gradio is solving is ultimately we want to build better machine learning models for interdisciplinary teams. Now, there's, I think, two aspects to that. One is if a model is bad, right? So if it's not robust, if it's going to fail, you want to detect that early, and you want to like detect the failure points of the model immediately before it goes into production. And the kind of the second aspect is if the model is actually good, you want to build trust around that model within your interdisciplinary team. And these are complementary problems, of course. And the reason it has been, I think, challenging to do this is because we expect machine learning scientists to do too many things. We expect them to train the models, but then also deploy the models often, especially in smaller teams. We expect them to deploy the models, and we expect them to build a database to collect incoming samples that are maybe causing the model to break, to put that detection framework there. And especially in interdisciplinary settings, we expect them to build like a front end or a demo as well around the model so that a wide user base can actually use the model. That is the problem that ultimately I think prevents a lot of models from being tested and identified as this is a problem early on. And so what ends up happening is that these models end up getting deployed, usually by somebody else who didn't train the model, and then by the time the problems are detected, it's too late, and that this iterative cycle is way too slow. So that's what Gradio is trying to solve, to make that, okay, everything else that you got to do, deploy the model, collect samples, build a front end, let's do that in Python. Okay, with just a few lines of code. Let's abstract that away because it's usually the same kind of code that's okay. So that's one problem. Now going to the second problem about actually building trust around the model. One of the things that we've seen, and this is super interesting, is that how do you actually build trust in a model? Think about it yourself. Someone gave you an algorithm. How would you learn to trust it? In the machine learning academic community, one of the most common answers to that question is, let's build interpretive tools. So we've realized that just giving like a high level aggregate metric of accuracy, this model is 93% accurate, is not enough to build trust, because people, when they see that number, they're naturally skeptical. So now what we've started to do is we started to build interpretation tools. Okay, but what ends up happening is that these interpretation tools don't necessarily correspond to how humans think about the problem. Okay, so they open up that black box, but not usually in the most natural ways. And people can sometimes be as skeptical of the interpretations as they are of the original kind of aggregate metric. So one thing that we've seen that works really well actually is letting the domain expert use their kind of domain knowledge to adversarially test the model. So they're like, okay, so I have this like just to give a particular example that we recently saw. So there's someone that deployed a model that looks at ultrasound images of the heart, and they deployed it to a doctor. And the doctor, okay, yeah, cool, this is making the right prediction. It's saying that there's a pacemaker in the heart and so on. what they did was they were using Gradio, which allows them to edit the input and use their domain knowledge to quickly manipulate the different things about the input. So they used the domain knowledge to actually edit out the pacemaker in the heart. And they saw the model's prediction change in real time. They're like, oh, from pacemaker to no pacemaker, and from various things. And they tried multiple things like that. And by the end of it, they were like, okay, this actually works. I've tested it on things that I think should be hard for the model, and it agrees with my intuition. And when that happened, actually, everyone in the room, even the machine learning researchers, we breathed a sigh of relief too, because it's one thing to know your model works in the abstract, but when it's actually tested, it still continues to work. So I think one big thing that we need to start thinking about is how do we build trust in these models? And I think a big solution to that is getting it in the hands of the people who want to use it as quickly as possible. Not having to go through these long cycles where you hand off the model to somebody else who deploys it, who sets up all this stuff. Let's just quickly get the model in the hands. If it's not working, let's iterate, let's improve it so that we're actually optimizing for what we ultimately care about, which is real world usage and not test accuracy, basically.
That's super interesting. I haven't actually heard that perspective quite put that way. So thanks for sharing that, Abubakar. And I think, Jakub, what you mentioned about the data scientists leaving with just literal black box of a notebook, I think is also very much what we think about at Comet a lot in terms of how our tooling for experiment management sort of, helps with that collaboration. So right on there as well. And you guys are doing a great job of sort of answering the next questions before. That's just a credit to you guys talking these things through and following the logic of how this would go. But I kind of want to pass it on to Drew's next question, because I think you guys talked about these sort of formative experiences or examples of things that led you to build your product. So I want to turn it over to Drew for this next question here.
Yeah, my next question was around challenges for collaboration, but I think we discussed that already. So I think I'll move on to my next question. So basically, I think the primary way that collaboration in ML happens currently is through code or papers. And I think both of you have built products that allow teams to dynamically interact with the models, data sets. How do you see from here, what is the sort of advancement in the tooling? Where is it going? What do you think it should enable us to do in the future?
Yeah. So I think one thing that we've been excited about is this thing that we released called Gradio Hub. And what that is, it's a place for, mostly academics are using it, as a place to release not just your papers, not just your code, but actually an interface, a demo for your model. And we think this is really important, again, in the interdisciplinary space, because most of the time the users of these models are not going to be computer scientists, let alone machine learning scientists. Oftentimes they are, for example, medical folks or other kind of domain experts, business users, and so on. And so I think it's really important to be able to actually let your models be, if you really, I think we've probably all had this experience. We saw a cool paper, we want to implement it. The code is available, but it's a mess. It's very hard to use. And I think hopefully, Jakub, with your notebooks, it's gonna be better going forward. But getting a model to actually work, even if when you have the code available, is not easy. And so I think being able to provide these user interfaces where anyone can immediately try out how a model is doing on their data set, I think is actually quite valuable. And we've seen it now. A lot of academics from the last NeurIPS conference actually uploaded demos and interfaces for their models, not just the code. So I think that's lowering the barrier to using these models even more. I think it's going to be really important. What we've done, I think, is the first step, but there's really a lot more that needs to be done, because what we've done is allowed someone to try out individual samples, individual data points on a particular model. But I think it would be super valuable for the purpose of reproducibility and for the purpose of accessibility if we could, easily compare a bunch of state-of-the-art models on this entire data set from all over the different domains. And I think Hugging Face, for example, is doing a great job with that, with NLP models, and now starting to look at other, domains as well. But I think we need more of that, where any published model, any published, code becomes immediately accessible and can be, plugged in as a baseline. I want to use this. I want to compare this baseline with this other baseline with my own model and see what's doing well.
I absolutely love what you said there, that I would like to iterate. You can't always expect that the audience, people that are going to receive and see and utilize your model, is going to be as technical as you are. Sometimes this might be true in an academic setting when you release a paper and there's going to be definitely a technical audience looking at this. But as soon as we move to a business setting, if you're working at a startup, it's not that your audience might be on average less technical than you are. It might be strictly true that actually every single person that's going to look at your model or dashboard is not going to be technical at all. And this is something that we have to understand, because let's look at this example. Let's see what happens. You are a data scientist. Maybe today you are not working on a model that's going to be put into production. Maybe today you are working on a dashboard. Like, you want to understand what is happening with your retention of your product. There was this huge spike 2 weeks ago. There's suddenly like this huge dip. Couple of days later, you want to dig deeper into this. And you are going to go, you're going to look at this problem. You're going to build an amazing dashboard that's going to show you like all these additional stats that you might need to debug this behavior. And you hand it over to the growth team, to a product manager, and they're going to look at this and ask, yeah, but 2 weeks ago, didn't we deploy some kind of uptime monitoring service, like something that's going to like automatically sign up for an account, click around 3 times, and then drop off? Did you filter out for this? And you have to answer this question. And it's not going to be just one-off question. Like, you can be sure that there's going to be another question, another question, another question. And there's going to be so many of them. And one thing that you can never allow to do in any well-functioning data organization is for data scientists to become a bottleneck for answering business questions. This is something that we've been trying to solve for quite some time. Like, this is something that we are spending a lot of time on, because it is a huge problem. There are many ways how to go about this. Something that we like to see is that whenever you publish a dashboard, you publish a model, like, you make the source available. This is almost becoming kind of the standard in academic setting. But even if you are in an industry, in a business setting, and you know that you are sharing this with people only within the company, there are no tools that are going to allow you to ship code alongside the dashboard to the stakeholders. They're going to receive a link. They're going to look at this link. There might be some filters, 3 or 4 filters. There might be some kind of a little bit of customization going on there, but inevitably they will want to see where this data came from. And even if you're technical, like if your audience is not as technical as you are, there is a chance they might be able to read that SQL query after you. Like, they might be able to check, did you put like that extra filter there? Like, how does your where clause look like? And suddenly you can not just significantly speed up the feedback loop, but you can also make sure that if your data scientist is on a holiday right now, like, they are never going to become a bottleneck for answering these kinds of questions.
Thanks, guys, for sharing both of those. Just want to take a second to I know some new folks have popped into the chat, just letting y'all know there is a Q&A section down below. We have our first audience question, which I actually want to turn to because I think it relates to some of these problems we addressed earlier as well. And it's from Harpreet, my good friend Harpreet, good friend of Comet and myself, Harpreet Sahota. What are some common pain points you've seen with respect to collaboration specifically? And I think this started to get referenced when teams start rapidly growing, say from it's like a data team's 1 to 2 to 3 to 4, and then all of a sudden you're at 10 people. I guess starting with you, Jakub, I'll let you start this one off. Are there things that you've seen, especially as you guys are building more tooling for teams and things like that, in that dynamic where teams start rapidly growing, and what are the specific pain points that they seem to face?
Let me take a step back here and first talk about the natural pain points of any kind of growth within an organization. No matter what kind of team you're growing, there are going to be certain where you will have to rethink how you are managing your team. You are starting a company and you are just a solo founder. The collaboration essentially doesn't exist because it's on by default. The moment that you have 3 people in a company, that's the moment where you start to think about, okay, maybe I should introduce some to-do list that might be shared between these people. Suddenly you have 10 people and your to-do list is no longer good enough. Like, you have to introduce some kind of regular weekly planning meeting or some kind of sync where you can talk about what are the things that you have been working on. Then you have 30 people, and there is no way you're going to just be told, like, all 30 of you sitting on the meeting. Like, suddenly you need to create some kind of hierarchical structure where there is going to be like a leadership somewhere thing, like deciding on like high level agenda. They might need to like split out into multiple separate teams. They're going to be focused on some sub problem of what you are solving. And data science team is not different from these principles at all. Like, they still have to follow like these basic rules of organizational scaling. What the things that actually happen, you might have seen this in the past yourself. If you have only one data scientist on a team, things are actually pretty easy. Everyone knows who to talk to. Everyone knows that, this person on Slack can get your question answered. The moment you have 3 people, it's still pretty easy to understand that, I have this my favorite person here. I talk to them all the time, and they all somehow divide the work between themselves. The moment you have 4 or 5 people and maybe 10 people, you just can't reasonably expect that you are going to message anyone on the team and receive the answer. That's the moment you start to see some kind of specialization. There might be data scientists or data analysts. And the best practices here is that data analysts, particularly, they need to be domain experts in order to answer questions. They just can't go out and solve any kind of problem without context. So you'll have to start formalizing things around, even though you have maybe a one data science team, there's all under one roof. I mean, there are multiple ways that we can manage your data science team. There will always need to be a domain expert dedicated to the finance team. There's going to be domain expert dedicated to the product team. There's going to be domain expert dedicated to a sales team. And these are the things that are going to just naturally happen in an organization. And there are, of course, so many of these. And we have, I'm not sure how much time we have here, but we could definitely go on for hours and just talk about all these things that are going to break with your collaboration. Someone prefers to write SQL this way. Someone prefers to just put commas at the beginning, and someone just created a completely new data warehouse and didn't tell anyone else about it. Someone just introduced a new filter to just change how data pipelines work. And you need to find ways how to do this. Fortunately, they're becoming, we are starting to see these patterns happening again and again, and we are starting to see frameworks. But again, that's quite a large question, and we might spend quite some time talking about this.
No, I think you did great, Jakub. Abubakar, any thoughts to add on that?
Yeah, no, I think that was a very comprehensive answer. I don't have too much to add, except that I will say that hearing Jakub's answer and basically mirroring my experiences as well, one promise of certain tools like Deepnote and Gradio and other, I think, great tech tools out there is that potentially you might be able to do more with one data scientist than you could ever before. And before, maybe you needed someone to build a front end and do this and do this. And now you can actually get away with a smaller team, which of course reduces the routing and specialization problems that Jakub mentioned.
Yep, that makes a whole lot of sense. Thanks, guys. I'm going to switch to something a little bit different. I'm always curious because I ended up in tech from this teaching, creative writing, mental health counseling background, and just backed my way into it. And now I feel like I have this interest in it that I didn't know I had. So I would just like to know what non-machine learning things hold your guys' attention. What kinds of things are you into, and hobbies, or whatever you want to call it, hobbies or interests or things that hold your attention. And are there things that then you see how they actually draw a connection between you and those interests in your work? So I'll start with you, Abubakar. Is there anything that sort of strikes you in that realm?
Sure. So I actually also love teaching and mentoring. I've been involved with various mentorship initiatives for a while now. I think it started very young. So I have 3 younger siblings. So I remember over the summer, teaching them and preparing questions, packets of questions and answers, and just teaching them different things and helping them study for the SAT and stuff. But since then, I've just been super, and by the way, this answer is kind of cheating because it does involve machine learning, but I've been teaching and helping a lot of students apply to PhD programs. And I've been particularly, I think applying to a PhD program and getting into a PhD program is a very cool opportunity because it opens up so many doors. I actually think one of the big reasons why we got VC money was because of Stanford, and I was saying, I'm going to leave this and work on this. And so, but obviously, and then other academic opportunities and so on. And so one of the things that I've seen, and which has been interesting to me, is now, these CS PhD programs are so competitive that in order to even get into these programs, you almost need to have done a PhD. You have to have papers, you have to have publications and so on. And so this is especially harder for people around the world who are applying from various parts, who they might not have this ability. They might be very talented, very smart. They've done really well in their courses, but haven't had this ability to do research. And one of the things that I recently started was this thing called the Fatima Fellowship, which is this ability it's open to students around the world, and they apply to this fellowship. And what we do is current PhD students or people who've graduated from PhD programs, they mentor them and supervise them on research. And so that's been my side project besides Gradio. And it's been really cool to see that, because it's been like a win-win situation. You have these smart, talented students who get publications and other research experience, and they're helping their mentors work on research projects that they would work on anyways. So yeah, that's just been something that I've been kind of part of. Other than that, to be honest, I don't get time for much else.
No, that's awesome. Thanks for sharing, Abubakar. How about you, Jakub?
So I already mentioned two things in my introduction a while ago. First of all, I did spend a lot of time in data visualization space. And this is related to machine learning, but at the same time, not as much. We are still working with data, we are still finding patterns, but the techniques that we are using are quite different, actually. Like this first data visualization world actually happens primarily in JavaScript, while the machine learning world primarily happens in Python. And there are just different approaches how you can get the answer. It doesn't have to be binary classification at the end of the day. It might be this beautiful visualization that you are going to just visually understand and see what is happening. So there were a lot of interesting things that I've seen as parallel. But there is also the other thing that I mentioned in my background, and that's background in developer tooling. And this, now we are getting into this counterintuitive situation that you might not expect. The better you are at writing code, again, I'm talking on averages, there's nothing doesn't apply to every single person. It becomes more difficult for you to enter data science and data analysis field, because once you get good at something, let's say you get really good at solving problems with software engineering techniques and building apps, you stay in the same tracks and you don't really go out and start looking at the problem in a non-technical manner. You might just jump into implementing a solution without really consulting the data set, doing some kind of early exploration, some data visualizations, and so on. And there is actually one really good example coming from the other way around, where data analysts, data scientists entered traditionally software engineering field and did something that probably no engineers would ever do. We might have noticed GitHub released recently a Copilot feature. And look, as a software engineer, I'm looking at this, I'm thinking, that's scary. I'm not exactly sure if I trust this code that's been generated by an AI. But at the same time, I'm totally forgetting about this huge number of people who are going to find so much value from autocomplete like this. Essentially people who are at the beginnings of their career, or just getting into a new programming language and might not have the new syntax as they are with some other language. And if you go out and talk to a software engineer, it's going to be very difficult to find someone who's going to be excited about working on this problem, because they know they wouldn't use it themselves. You switch it around, you start to talk to data scientists, and they're just like, oh my God, this is the coolest thing ever. We are going to build this, and just don't see the same problems. And as a result, they can find interesting new innovations. Even if you personally don't use them, it's something that's definitely cool to look at and to study and see what are the limitations of it. And definitely it's bringing a lot of value to a lot of people out there.
Awesome. Really appreciate those answers. Definitely try to get you all away from the machine learning and the coding a little bit. You can't take it out of the people. That's just how they are. You can't do it. So we've got about 10 minutes left or so. I'll probably try to wrap up with just a minute or two left, but I'm getting a couple more questions coming in from folks in the audience. So I want to turn to those. And I think one that's particularly connected. Abubakar, you were mentioning teaching and mentorship, and I was reflecting that as well. Another question from Harpreet, and then I've got a question in chat that I want to address too around security. But first, speaking of mentorship, this is from Harpreet again. We have a lot of folks in our community as well that are learners, that are reskilling, that are just trying to figure out what skills they need to learn, in addition to just how do I model X, Y, and Z. Also, what skills do I need to boost my status in an interview process or take that next step. So speaking of this mentorship, what advice would you give to people that are breaking into the field, that are doing projects of their own? What can they do to start developing this sort of collaborative mindset? What parts of that experience are amenable, do you think, to that sort of collaboration? And whoever wants to take this one to start, go for it. I think Abubakar, you're muted. It looks like you're deep in thought, but yeah, there you go.
Yeah, thanks. Yeah, so one, I think general piece of advice that I give to folks that are breaking out is that work on projects as soon as you can. I think there's a tendency sometimes we feel like we need to learn everything first and then we can work on projects. But especially in machine learning now, so many things have been abstracted away that if you just focus on all of the theoretical material or like the material in lots of like traditional classes and stuff, you'll actually find that a lot of it is dry and actually not actually very relevant to what you actually need to build models. So my suggestion would be to work almost backwards and say, okay, I have this particular idea in mind. And the idea could be, you could get ideas from a lot of different places. It could be something from your own personal, like maybe something you enjoy doing, turn it into a data sciencey type problem. Or it could be like, I saw this DALL-E Mini, maybe you guys have seen it on Twitter and stuff, a project that's based off of trying to adapt an existing work and then try to actually implement it, try to actually go out and implement your project. And I think you'll find what you actually need to learn. And you could find collaborators. I think one of the great things about the DALL-E Mini project is kind of came together online, I think on Twitter and some different places, because people obviously get hyped up about projects. Yeah, start working on projects and real applications as soon as you can.
Totally agree with this. And I just want to add one more thing. What I have seen happening in academia is that despite everyone's best efforts, the students tend to forget about the importance of domain knowledge. And this is so powerful, especially as you are entering the field, because you are, let's say that you want to work for a company that's doing data analytics for movie studios, right? You can come in with all these crazy math and stats skills, and there's like this many PhDs and so on. But if you can come in with an insight and realize that, oh my God, like at the end of the day, like there is a human being making a decision how many screens to put the Star Wars on, then no matter like how good your model is going to be, you just can't beat this one singular human being that's going to essentially completely wipe all the predictions from your model because they just woke up in the morning and thought, yeah, the new Star Wars movie doesn't look that good. I'm just going to put it on 1,000 screens instead of the usual 1,500. And this is just like the general like excitement about the domain can get you so far in solving real problems. And if your goal is to get a new job or get an internship or just like level up your skill, this is literally the biggest unfair advantage that I have seen, because even though looks like it kind of seems natural, most of the people just forget about it and they realize like you should do your research before you get into solving a particular problem.
Definitely.
Yeah, I think those are really great points. There's a couple questions in the chat here that I want to package up together. And I think this really is like a tension point with tools that are meant to be open and collaborative and shareable and testable quickly and iterative and things like that, is how do you guys think about security, privacy regulations, security best practices when working with a client, or when people bring up things about whether it's EU's sort of GDPR, other privacy data sharing regulations that I know nothing about, frankly. But I'm just curious how you guys think of that with the mindset of also being like, we want to be super open and collaborative and sharing and community-based in that way. Like, how do you work with that tension? And it might look different for both of you, understandably, the tools you build, but how do you guys think about that at a bigger picture?
Yeah, definitely. So I can quickly talk about this. So we deal with security all the time because many of our clients, many of the people who use Gradio use it in clinical settings. So like to validate clinical studies and so on. So there's patient data involved and so on. So we've built a few things into Gradio to address this. For example, authentication, encryption. So any data that gets stored using Gradio gets encrypted and so on. So there's a few standard kind of set of things that we do. And then we also built an entire version of Gradio that's like on premise. So that you have full control of the data and the model and so on. So I think we've taken like different layers, different versions of the product, depending on what was needed. So like the one that's on premise, that one has some code that's not open source because it needs to be that way. So we've ended up creating different versions depending on what the use case is. One other thing that I think about, which kind of is related to security, but maybe not exactly, but I do think a lot about how as machine learning is maturing from this research stage to this like real software engineering stage, one thing that we need to think about a lot is like, is our code going to actually work properly when deployed? Like real code, it comes with a lot of guarantees. We have in our mind, whenever we have a function, we have precondition. Okay, this is what should go inside the code. Post condition, this is what we expect from the code. But in machine learning models, we don't quite have that right now. So I think one thing going forward is we're going to see a lot more of that, more robust conditions and guarantees on how machine learning models are supposed to perform.
Thanks for that. Jakub, anything you want to add there?
This might be quite a long answer, but I'll try to keep it short. What we have seen is that it sounds like when you first look at the problem and you are saying, oh, like I have so many security related worries and considerations, and I just can't allow this crazy new idea of putting the whole organization and giving them access to a data platform. What is really happening in reality is that you are like 99% of the time better off having a centralized place, like a data platform, to do as much of your data science work as possible, rather than trying to segment it out and let people find their own ways how to deal with lack of access. Because the moment you have some kind of sensitive data set that only a select number of employees can have access to, it is literally just a matter of time until someone sends a CSV file over email to someone else who is not supposed to have it, and they'll just have it forever. There is no way you're going to get it back, because in the first place, you don't even know that they have this file. If you have everything in actually truly collaborative environment, there are probably all these built-in features that you can rely on. There is audit logging, there is history. It has like proper authentication model built out. So you can be very selective around like who can access this specific model, who can access this specific notebook. And if you misconfigured something and you found out 2 weeks later that, oh my God, like this like super sensitive column in my schema was open to the whole organization, you don't have to go and reset everyone's credit card info. You can just see what actually happened, and like you can have full audit access, log of all the accesses to this particular piece of information, and you can make better decisions around it.
Awesome. Well, I think that's where we're going to have to leave it. We ran out of time, which is awesome. Thank you so much to everybody who came, who stuck around, who asked great questions. Nikunj, I just hope I'm saying your name right. Sorry we didn't get to your question. Just a lot of great ones here that we wanted to get to. But thanks so much to Abubakar and Jakub. Stay tuned. We will have more coming in the future, more Comet industry Q&As with folks from around the industry, different themes, things like that. We have a lot of exciting things planned. But for right now, thank you so much to Abubakar and Jakub. I'm going to do the if we were live, like a round of applause sort of thing to close this out. Thank you so much. And we will put this, we're going to chop it up, put it online, share it in a few different ways. We got some plans for this. So stay tuned and check out Gradio and Deepnote, the two awesome companies that we found to be very useful for the work we do as well. So thanks so much. And thanks, Drew, for helping me run this and co-hosting. I know I drove the rest of the second half of it, but I thank you for coming up with those questions and everything like that. Yep, gradio.app, and then it's deepnote.com. Those are the two sources, right? All right, check those out. And until next time, everyone, thanks so much again, and stay safe and take care. Bye, everybody.
Yeah. Bye, everyone. Thank you.
Yeah.